Hello everyone, welcome to Explore Hall. So for this example, we're given the following table which shows the distribution of income in two small towns, Town A and Town B. Suppose that a random household is selected from the data. Then we let A be the event that the household earns an income above $80,000 and B be the event that the household is from Town A. And we're asked to determine whether or not events A and B are independent of each other. Let's first start by determining the probability of event A, which is the probability that a household earns an income above $80,000. To find the probability of event A, we simply take the total number of households that earn an income above $80,000 and divide it by the total number of households in the data. So the probability of event A is equal to 28,750. Since we got a total of 28,750 households that earn an income above 80,000, divided by the total number of households, which is 125,000. And this is equal to 23 over 100. Now to find the probability of event B, which is the probability that a household is from Town A, we take the total number of households from Town A and divide it by the total number of households in the data. So the probability of event B is equal to 50,000 divided by 125,000, which is equal to 2 over 5. Now let's find the probability of the intersection of A and B, which is equal to the number of households in Town A that earn an income above 80,000 divided by the total number of households. And we see from the table that 2,500 households from Town A earn an income above 80,000. So the probability of the intersection of event A and B is equal to 2,500 divided by 125,000, which is equal to 1 over 50. And from here, we can now find the conditional probability of B given A. So the conditional probability of B given A is equal to the probability of the intersection of A and B divided by the probability of event A, which is equal to 1 over 50 divided by 23 over 100. And this is equal to 1 over 50 times 100 over 23, which is equal to 2 over 23. And we can see from here that the probability of B given A is not equal to the probability of event B. So we can see that the probability of B given A is not equal to the probability of B, since 2 over 23 is not equal to 2 over 5, which therefore means that events A and B are not independent of each other. And that's it for this example. Thank you for joining us. See you in the next lesson.